So this video is going to focus on section 2.3, solving linear equations. And when we do that, we're going to look at the four-step process for solving linear equations. We're going to then essentially add a fifth step, and I'll show you what that is. And then we're going to talk about how do we do these equations when they have fractions and decimals, and what are some things you can do that make it easier. And then finally, we're going to talk about how we can get what's called just a unique solution, or an infinite number of solutions, or no solutions at all. So we'll talk about what happens when you solve. All right, that's it. Here we go. So the four-step process to solve a linear equation. These four steps are always the same, and then just for kicks, I'm going to add step 5 here. Now, I want to remind you, step number 1 is deal with all distributive properties. Now, I'm going to show you how we can introduce more distributive properties than the distributive properties we see. But once we deal with all of them, then you are done with that step. Then we go to step 2, and as we said in class, this is collect like terms when those like terms are on the same side of the equation. All right? Basically, you just add. Then we collect like terms. Our text often calls this isolate the variable, where we move like terms to opposite sides of the equation and we group them. So I call this opposite side collecting like terms. And we do that by using the addition property of equality. And then finally, we use the multiplication property of equality to solve for x. And this process never changes. It can stay the same. You just have to pay attention to distributives that are shown and that are hidden. And I'll show you how to deal with that. The like term issues and the multiplication property of equality. And then that takes us to the last step, and which I often don't call a step, but I do almost all the time, and that is check your answer. And we check our answer by plugging it into the equation, by evaluating. And the more you do this, the better you'll get at doing these kinds of problems. Let's do a couple of examples. Okay, our first example, when we look at the problem, essentially kind of what you do is you just look at half the problem at a time. So say you want to look at this left half, and what you see is you see a distributive property. Now, the way they talk about it in your text is you just want to simplify everything. And that means do the distributive properties, then collect like terms. And that's essentially what we're going to do. So what we want to do, our step 1, and I'm just going to put step 1 out here, is do all the distributive properties. So I'm going to take the 4, and I'm going to multiply it by everything in the parentheses. So I get 8x minus 12 equals 32. And then once I'm there, I now notice my step 2. Are there like terms on the same side of the equation? The answer is no. There are no like terms on the same side. So I essentially skip that and I go to step 3, which is, are there like terms on opposite sides? And the answer is yes. 12 and 32 are like terms, so I need to use the addition property of equality. I'm going to add 12 to both sides to move the 12 to the right side of the equation and isolate the 8x. So I end up with 8x equals 44. And now once I'm here, I use the multiplication property of equality, multiply both sides by 1/8, or the same thing, divide by 8, and I end up with x equals 44 divided by 8, which reduces to 11 over 2. When you, if you rewrite this as 4 times 11 over 4 times 2, the 4's then make 1, and so you're left with 11 over 2. And now we check it. This is really our step 5. And so we go 4 times 2 times 11 over 2 minus 3. And we want to see if we get 32. So that's 4 times 11 minus 3, which is 4 times 8, which is equal to 32. So it checks, and I now know that this is the correct answer. Okay? Let's go on and do another problem. So next problem, slightly more difficult. Let's go 7 times 3x minus 2 plus 5 equals 6 times 2x minus 1 plus 24. All right. Now, in this one, in much the same way, I see a couple of distributive properties. So I do those first. So this is 21x minus 14, 7 times 3x, 7 times negative 2, and then bring the plus 5. And then on the right side, 6 times 2x is 12x, 6 times negative 1 is minus 6, plus 24. So that's step 1. And then step 2, are there like terms on the same sides? The answer is yes, I got like terms on the same side and like terms on opposite sides. So we'll do the same side stuff first, just arithmetic. 21x minus 9. Negative 14 plus 5 is negative 9. And that gives me 12x. Negative 6 plus 24 is plus 18. Now I have like terms on opposite sides, so I need to get the variable terms by themselves and the numerical terms by themselves. So I'm going to add 9 to both sides. That will move all the numbers to the right side because this will be 0. And then I'm going to subtract 12x from both sides. And that will move the 12x to the left side. And because 12 minus 12x is 0. So we are now left with 9x equals 27. Step 4, multiplication property of equality. Multiply both by 1/9 or divide by 9, and I get x equals 3. So then I want to check this, which is my step 5. So I go 7 times 3 times 3 is 9 minus 2 plus 5. And that's equal to 7 times 7 plus 5, or 49 plus 5, which is 54. And then the right side is 6 times 2 times 9 is 8, or 2 times 3 is 6, minus 1, plus 24. And 6 minus 1 is 5. So 6 times 5 plus 24. And that's 30 plus 24, which is 54. So both sides are equal, therefore it checks. Doing this check work helps you get better at doing basic arithmetic without using a calculator. Although you can use a calculator to do these checks as well. Alrighty, next, there's a couple of examples. So let's move on and add some hidden distributive properties. So what happens is you might have a fraction that shows up in your equation. And you can do the work like we normally would. You could add 9 to both sides. There's no distributive property, so I just add 9, none visually. And then when I get to this step right here, what I do, I want to divide by the number in front of the x. And so that means I divide by 3/4, I divide by a fraction. Well, that always freaks people out. So that's why always thinking multiplication. So what we do is we multiply both sides by the reciprocal. 4/3 times 3/4 x equals 4/3 times 3. And this will give me 12 over 12x, which is 1x. And then the 3's will cancel here, and I'm left with 4. And then you can go back and check this, and it'll work. And so that's okay. But a lot of people, a lot of students I've had in the past freak out with these fractions. And so while you can do it following the normal procedures, let me show you something different. What if I had 3x over 4 minus 9 equals -6? What we can do is we can introduce a distributive property. So what we do, and really what it is in our step 1, where we do distributives, we introduce one by using what's called the multiplication property of equality. So the thing we do last, we now do first as well. So what I do is I multiply both sides by the common denominator. So 4 times 3x over 4 minus 9 equals 4 times -6. Now, on the right side, that's not bad. I get -24. But on the left side, what happens? Well, I get the -36 when I multiply by -9. But what happens when you multiply 4 times 3x over 4? Well, it turns out that the 4's will cancel. So you get 4, or 4 over 1 times 3x over 4. And the 4's cancel, and you're left with just 3x. And so what happens is by using the multiplication property of equality, which introduces a distributive property, you end up turning the problem into a problem without fractions. So instead of having to think of dividing by a fraction or multiplying by the reciprocal, you just do what I call clear fractions. Okay? Then we add 36 to both sides. We get 3x equals 12. And then we divide by 3, following our procedures, and get x equals 4. And it's the same thing. And now you might think this looks longer here on the right, but it looks longer because of what I was talking about. And where this really helps is when you have more fractions. So let's look at a much more complicated problem. All right, let's go with this one here. Y over 3 plus 2/5 equals y over 5 minus 2/5. Okay? So when we look at this, what we see is the least common denominator is 15. So we take 15 times y over 3 plus 2/5 and 15 times y over 5 minus 2/5. In other words, we make a distributive property problem out of it. Now we take that 15 times y over 3 plus 15 times 2/5 equals 15 times y over 5 minus 15 times 2/5. All right? And now we notice 15 over 3 is 5, so we get 5y. 15 over 5 is 3. 3 times 2 is 6. We get 6. 15 over 5 is 3. 3 times y, 3y. 15 over 5 is 3 times 2 is 6. All right? And so now we've made this problem much simpler to do. So by introducing a multiplication property of equality, we introduce a distributive property that clears the fractions. And we do this first. All right? And so now I'm going to subtract 6 from both sides to get rid of the 6 on the left, and subtract 3y from both sides to get rid of it on the right. There. And so I'm left with 2y equals negative 12. And then we divide by 2, so y equals negative 6. And then we can go check that. Negative 6 over 3 plus 2/5 is equal to negative 2 plus 2/5, which is 8/5, or negative 8/5, negative 1 3/5. Or you can do the common denominator and get that. And then we do negative 6 over 5 minus 2/5 is just equal to negative 8/5. So it checks, so I know I have done the problem correctly. Okay. All right. So what you have to decide is, do you want to do what I've done here, or do you want to take this problem, y over 3 plus 2/5 equals y over 5 minus 2/5, and then you subtract 2/5 from both sides, and subtract y over 5 from both sides. But then you got to do all the common denominator stuff. Now over here, this isn't bad, it's negative 4/5. But over here, you now have y over 3 minus y over 5. And now you got to do the common denominator and so forth. And so this is what really happens in most of the problems, not what happened in the first one where it gets longer. And this makes it longer. So what your choice is, do you keep it as multiplication, or do you keep as addition? And so if you keep as addition, you're going to be adding, finding common denominators and so forth. To do multiplication, you multiply by the common denominator, and that clears the fractions. You have no more fractions. So that's what you have to think about. All right, let's do one more of these. Something's a little tougher. You play the, whoops, I apologize. So as you can see, this one looks even more complicated. But as I look at it, I see the least common denominator is equal to 12, because 3 and 4 are the denominators. So what I'm going to do is I'm going to multiply each side by 12. Okay? Now, one way you can help yourself here is you can make it 12 over 1 so you can see it's a fraction. All right? Now, when we multiply this, it becomes 12 times x minus 2 over 1 times 3 minus 12 times 4 equals 12 times x plus 1 over 1 times 4. Now, I write this out so I do the multiplication correctly and actually see the distributive properties I create. Now that I've written it out, now I'll do the distributive properties. So this becomes 12x, well, pardon me, excuse me, let me show you something here. All right. What you'll notice is that you have the fraction 12 over 3 here. which is really 4 times x minus 2. And right here you have 12 over 4, which is 3 times x plus 1. So in other words, I have now turned this problem from a fraction problem that looked pretty ugly into a linear equation with a distributive property. So now I just do the distributive. 4x minus 8 minus 48 equals 3x plus 3. And then I collect like terms on the same side. 4x minus 56 equals 3x plus 3. Then I subtract 3x from both sides and add 56 to both sides. And I end up with 1x equals 59, because this goes to 0 and that goes to 0. And I'm done. And then I can check it. Okay? The check is interesting here because if you go to check it, you get 59 minus 2 is 57 over 3 minus 4, which is 19 minus 4, which is equal to 15. And on the other side, you get 59 plus 1 over 4, which is 60 over 4, or 15. So since both sides are equal, it checks, and I've done the problem correctly. All right? Now, this same strategy can apply to problems with decimals. So for instance, if you have 0.1 times 2z plus 6 plus 2 equals 14 minus 0.2x, okay? So if you have decimals in there, sometimes that can mess you up. You drop a decimal, etc. So what you do is you play the let's get rid of the decimals game. So the first thing I do here is I get rid of this distributive. So that's 0.2z, or excuse me, x. Should have put an x there. Plus 0.6 plus 2 equals 14 minus 0.2x. So if you have a quick distributive you can do, go ahead and do it, and then do the fraction or decimal thing. Since these are tenths, 0.2, 0.6, and 0.2, just multiply both sides by 10 to get rid of the decimal. So then you have 2x plus 6 plus 20 equals 140 minus 2x. And now you just proceed like normal. 2x plus 26, 140 minus 2x, like terms on the same side. Collect like terms on opposite sides, add 2x to both sides, subtract 26 from both sides, and you get 4x equals 114, and then that divide by 4, and you get x equals 57 over 2, and then you check it. Okay? And since this is a decimal problem, a lot of times you would then go ahead and write your answer as a decimal in this case. So you would write 28 and a half. And that would be either one of the, I'd accept either one of those. All right? Okay, that was a lot of equations. Hopefully that helped clear up some of the issues. Now, there's one other thing that happens that we want to talk about. I'm going to give you 3 simple equations, okay? Suppose I give you 3x equals 3x plus 1. If I solve this, I subtract 3x from both sides, and I get 0 equals 1. So I want you to think about this for a moment. Just think about it, okay? And then what if I have 3x equals 4x plus 1? This is sort of normal. Subtract the 4x from both sides. And we get negative x equals 1. So we divide both sides by negative 1. And we get x equals negative 1. Now, in the same way, I want you to think about this answer right here. Okay? And then the next question, what if you get 3 times x plus 2 equals 3x plus 6, okay? And so that's 3x plus 6 equals 3x plus 6. And then you subtract 6 from both sides, subtract 3x from both sides, and you end up with 0 equals 0. Okay? And we want to think about this as well. So, all the problems we have done up to now are like this. When you do them, you actually get an answer. You get x equals some number. This is what we call, this is the situation of a unique solution. Okay? And it happens because the x terms and the number terms aren't exactly the same thing. All right? Now, what about this one up here? Okay? This one says 0 equals 1. Is that true? No, that is a false statement. If you get a false statement, that actually means there is no solution. So a false answer is like 0 equals 1, 2 equals 5, 1/2 equals 4/3. If it's a false statement, it's always no solution. Okay? However, if you get a true statement, like 0 equals 0, 1 equals 1, 2 equals 2, 1/2 equals 1/2. If you get a true statement, that means infinite solutions. That means your x value can be anything. Anything will work. All right? And your book writes it like this: the set of all x such that x is a real number, which is another way of saying all real numbers are a solution. Okay? So unique solutions, no solutions, infinite solutions. This is something that's going to happen again, so it's something you want to pay attention to. Alrighty, that's all I have for you on this video. See you later.